Good morning, children. I hope that everyone is fine and staying home safe and healthy. This pandemic has brought about a great change in everyone's life, which we never expected of. But we all have accepted this challenge, and the new system of online teaching has helped the students to become more of self learners and understand their self strength. I have seen that some of the students have done really good, and I hope that in the near future, all the students are with their textbooks and they're doing their work sincerely and showing their best in the truest sense. Thank you, children.
Hello students, I am Sandhya Kathuria, your physics teacher. Hope your studies are going well and your learning will certainly improve further. Today we will study lesson number 2 of your book. The name of the lesson is Physical Quantities and Measurement. Children, you already know what are physical quantities. All those quantities which can be measured are known as physical quantities like length, mass, time, temperature, volume, density. All these quantities are known as physical quantities. My first topic for today is density. You know, each body has a certain mass and a definite volume. The volume increases if its mass is increased. The mass increases on increasing the volume. Further, equal masses of different substances have different volumes. For example, if you take 1 gram of cotton and 1 gram of lead, their mass is equal, but the volume of cotton will be much more than the volume of lead. This is because the particles of lead are closely packed. This means lead is denser than cotton. Similarly, equal volumes of different substances have different masses. For example, if we take 1 meter cube of iron and 1 meter cube of wood, the volume is equal, but the mass of iron will be greater than the mass of wood. This is because the particles of iron are closely packed. This means iron is denser than wood. Thus, to explain that equal masses of different substances have different volumes and equal volumes of different substances have different masses, we use a term called density. The density of a substance is its mass per unit volume. That is, density of a substance equals to mass of the substance upon volume of the substance. In this chapter, we will denote density by the letter D, mass of the substance by the letter M, and volume of the substance by the letter V. Now, how will you get the units for the density of a substance? Children, you know, the SI unit of mass is kilogram and the SI unit of volume is meter cube. So, the SI unit of density becomes kilogram upon meter cube. That means kilogram per meter cube. Similarly, the CGS unit of mass is gram and the CGS unit of volume is centimeter cube. Therefore, the CGS unit for density becomes gram per centimeter cube. My next topic is relationship between SI and CGS units of density. You've already studied that the SI unit of density is kilogram per cubic meter and the CGS unit for density is gram per cubic centimeter. Thus, 1 kilogram per meter cube equals to 1 kilogram upon 1 meter cube. You know, 1 kilogram equals to 1000 grams and 1 meter equals to 100 centimeter. So, this becomes 1000 gram upon 100 centimeter whole to the power 3. That means 1000 upon 100 into 100 into 100 gram per centimeter cube. So 3 zeros are cut with 3 zeros. That means 1 upon 1000 gram per centimeter cube. In standard form, you can write it as 1 upon 10 to the power 3 gram per centimeter cube. Thus 1 kilogram per meter cube equals to 10 to the power minus 3 gram per centimeter cube, or 1 gram per centimeter cube equals to 1 upon 10 to the power minus 3, which becomes 10 to the power 3 kilogram per meter cube, or 1000 kilogram per meter cube. Thus, to convert kilogram per meter cube to gram per centimeter cube, you will divide by 1000. And to convert gram per centimeter cube to kilogram per meter cube, you will multiply by 1000. Next, I'll tell you the determination of density of a regular solid. Regular solid means which is having a definite shape, like a cube, cuboid, sphere, cylinder, etc. Step 1 is to measure the mass m of the regular solid by means of beam balance and note it down with the proper unit. Second, find the volume V of the regular solid. The volume of the regular solids can be determined by using the formulae, like the volume of cube is given by side cube. Volume of cuboid is given by length into breadth into height. Volume of sphere is given by 4 upon 3 pi radius cube, and so on. The side, length, breadth, height and radius can be measured with the help of meter rule or the vernier calipers, etc. Now the last step is to substitute the values of mass and volume in the formula of density, which is D equals to m upon V. So you will get the density of that regular solid and you will give your answer with the proper unit. Now children, I am going to show you some vessels for measuring volume. In class 7, you have read that we use different vessels for measuring the volume of liquids. So in your book, some vessels have been shown. First one is measuring cylinder. It is made up of glass or plastic and it is graduated in milliliter with a 0 mark at the bottom. The graduations then increase upwards. We have measuring cylinders available of different capacities such as 50 ml, 100 ml, 200 ml, etc. The capacity of a measuring cylinder is marked on it. The next one is a measuring beaker. A measuring beaker is made up of glass, plastic or metal like aluminium. It is used to take out a fixed volume of liquid, say milk, oil, etc. such as 50 ml if you want to take out. Suppose 100 ml you will use this one and 200 ml. Children, you must have seen these beakers with the milkman daily. The capacity of measuring beaker is marked on it. The next vessel is a Eureka can. A Eureka can is a glass or metal beaker with a side opening near its mouth, which is known as spout. Thus the beaker can contain a volume of liquid up to the spout. Any excess of liquid overflows through the spout. My next topic for today is determination of density of an irregular solid. Irregular means it doesn't have any particular shape or size. Like a stone, if I give you, how will you measure the density of the stone? To determine the density of an irregular solid, we have to measure its mass and volume. The mass of the body is measured with the help of beam balance. And to measure the volume, we use the displacement method. That is, a solid when immersed in a liquid displaces volume of liquid equal to its own volume. The measurement of volume of an irregular body by displacement method can be understood by the following activity. Step 1. Measure the mass of the given solid using a common beam balance and note it down. Let it be m gram. Now you take a measuring cylinder like this, partly fill it with water. As shown in the figure, let the initial level of the water in it is V1 ml. Now you tie the given solid with the thread and you immerse the solid in the measuring cylinder. Take care that no water splashes out. Now you will see that the level of the water will rise because the stone has taken some place in the water. Note it down this level of water again. Let it be V2 ml. So the difference V2 minus V1 will give you the volume of the solid. Therefore, V equals to V2 minus V1 centimeter cube. Then calculate the density of the solid by using this formula, which you know, density equals to mass upon volume. If M equals to 78 grams and V equals to 10 centimeter cube, then density will become 78 upon 10, which is 7.8 gram per centimeter cube. This is all for today, children. Thank you so much.